Sample problem 19.2. A galvanic cell consists of a magnesium electrode in a 1 molar magnesium nitrate solution and a cadmium electrode in a 1 molar cadmium nitrate solution. Determine the overall cell reaction and calculate the standard cell potential at 25 degrees C. So a couple comments about this. The concentrations of 1 molar are not going to be used in the calculation, but that number is there to remind us that we can use standard cell potentials because any ions are 1 molar. The electroactive ions, which are cadmium and magnesium, have a concentration of 1 molar. So we'll use the standard reduction potentials. The cell potential, which they call the overall cell potential here, is again the standard reduction potential of the cathode minus the standard reduction potential of the anode. Cathode minus anode. You just have to figure out which one is which. So we have magnesium. And take a look at what it becomes when it's an ion. It's MgNO32. Magnesium is a group 2 metal. That makes it pretty easy. It's in group 2A. So that right there tells you it's magnesium 2. So this is a electrode that has magnesium, and I'm going to put a little slash there just to indicate it's also got magnesium 2. That's easy. Other one, cadmium nitrate. Same idea though. We don't, cadmium is not as simple to figure out what its charge is, but the nitrate is -1, and there's 2 of them, so this has got to be +2. So it's cadmium and cadmium 2. So you go look them up. You just look them up in the table here. So we're going to look up cadmium and magnesium. They're both negative. That's fine. Here's the cadmium. I see that one right there, and it has a standard reduction potential of -0.40 volts. Magnesium is further down. The alkaline metals and the alkaline earth metals are pretty negative. They're easily oxidized. So it's at -2.37. So there's our potentials. So this one's -0.40. And this one's -2.37. So which one's higher up? The cadmium is higher up, so that's the cathode. The one that's higher up is the cathode. The one that's lower down is the anode. More positive cathode, more negative anode. So that means the standard cell potential is simply -0.40 minus a -2.37. It's a simple problem, so we'll go through the arithmetic. This becomes +2.37. Oops, 2.37 volts, right? So you get 1.97 volts, right? Is that right? Yep. There we go. So this, it would generate almost 2 volts if we made this here together. It also says to determine the overall cell reaction. That's easy enough. The anode is oxidation. They both start with vowels. So that means that this is going to be oxidation. So it's Mg goes to Mg2 plus 2 electrons. The cathode is reduction. Okay, that's this one. So that would be cadmium 2 plus 2 electrons goes to cadmium. Remember, this is just the reverse of reduction, so you can look it up in the table and just make it go the opposite direction. Luckily for this one, the 2 half reactions have the same number of electrons, so when you add them, they cancel. So you get Mg plus Cd2 goes to Mg2 plus Cd. And there we go. We got it. That's our overall reaction. That's our cell potential. We've completed it.